So let's come back and do the 17th question of your CBSE board paper, that is 2018 and 19. Right. When I come back to 17th question, so let's see this. Here, complete the following questions are quite common in section C. Remember that. Right. So here they've given us this. Okay. Then. And they've given us hydroxylamine. So simple. Whenever you see such reactions, hydroxylamine, or you're taking semi-carbazone, reactions of aldehydes and ketones, very simple, nothing to remember. You have to just take out water molecule from here, okay, minus H2O, and directly write the compound. Nothing to change. You're not going to change any bonds and anything. Just write the compound. Double bond is here, H. Simple, isn't it? Yeah. So when I come back to this, so what is important? What should you remember here? K1O4 is an oxidizing agent. Remember that. So whenever you're taking cyclohexene, important. This is a different reaction, right? So here they picked up that reaction, but as such, whenever K1O4, that is acidified K1O4 is there, it is an oxidizing agent. But here, what is it going to do? It's going to break up this bond here. It will break up, and it's going to form a compound. Means it's going to add carboxylic acid, because acidic medium we have taken, isn't it? It's going to add carboxylic acid on both the ends. You have a carboxylic acid just like this only. It's going to add, but what is important is it's going to form a straight chain and here, right? So what is the role of K1O4? Here, your concentrated K1O4, that is an acidified K1O4, it leads to cleavage of bonds. Remember that, of bonds. And also acts as oxidizing agent. So what does it do? It's going to add COOH on one end, COOH on other end. But how many carbons do we have here? You see here 1, 2, 3, 4, 5, 6, isn't it? So just let's write. This is 1. Already this is 2. This is the third one. This is the fourth one. This is the fifth one. This is the sixth one. Okay, I have made it a smaller chain. Join it here. Okay, that means how does this look? This looks like COH group on one side, then CH2, CH2, one more CH2, one more CH2, COH. Okay, total number of 6 carbons. 1, 2, 3, 4, 5, 6. This is the answer, right? So now, when I take the next question, what are you saying? What is here given? What important thing should you observe here? Here they have given this reaction or this particular thing. No, it is nothing but Gabriel phthalimide synthesis. Right, so Gabriel phthalimide synthesis, how is it given, ma'am? How is it prepared? So let's see the whole reaction and then come back to this in the presence of ammonia, right? Okay, this is an intermediate given to us. So first important thing when I take, I'll be taking this phthalic acid. This is nothing but I said Gabriel phthalimide synthesis. Take this phthalic acid first. You're going to add ammonia. Then what does it form? It's going to form a compound which is in equilibrium with. This is going to form an intermediate first. Then you get added to this. This becomes COO NH4 plus and COO NH4 plus. But this is called ammonium phthalate. This is phthalic acid. This is ammonium phthalate. Then further what happens? This ammonium phthalate, when you're further heating it, it's going to form a compound called phthalimide. Remember that. Okay, this is ammonium phthalate. That is done. Further, when I heat this, it's going to lose this hydrogen from here, and you're going to get this is CONH2 or NH2. Okay, right. Now further, when you heat this, now what are you going to do? You're going to do here you're heating it and removing 2 water molecules. That is what's here, H2O, 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 H2O. So you got this. Now what are you going to do? You're going to do strong heating here. Then finally you're going to get a compound. See here, there is a cleavage. Yeah, let's see here exactly. CO is retained here, N and H is retained, and NH3 is out. So I get a final product, that is with your C double bond O. This also C double bond O, and what is the compound? NH. Okay, this compound, this is called phthalimide. This is a answer. So hope students this is clear. Phthalic acid plus ammonia, it's going to add around these two hydrogens and you get this intermediate product. This one heating, it loses, what is it doing? It's going to form phthalimide, isn't it? Right? So here what is happening? This one is not here, it is not losing a water molecule. Here it is losing two water molecules. Further on strong heating, ammonia is out and finally phthalimide you get. So this is a compound. Done. So let's see the next question. What do they give me here? Give reasons for the following. Use of aspartame as an artificial sweetener is limited to cold foods only. What is the reason they said? Right. So first of all, whenever such reasoning questions are given to you, remember, instead of writing a direct answer, you have to be a bit careful in answering. Aspartame. What is the speciality of aspartame? See here. They said use of aspartame. That means if I use aspartame as an artificial, means aspartame is used in artificial sweetener, it is limited to cold foods. Means only cold foods only I can use aspartame. I can't use it in hot foods. What will happen when I use it in hot foods? That is the question. Right. What should you remember? First of all, whenever you take aspartame, okay, and when you do, means when it is exposed to high temperature, that means when you heat it, what will happen? This aspartame is going to release a substance, or it's getting converted to a substance called phenylalanine. This phenylalanine is harmful in nature. So this is the reason. Aspartame, which is a non-saccharide sweetener, means a sugar substitute, because it gets converted to a harmful substance at high temperature, it is only, you write this, since aspartame gets converted to phenylalanine high temperature, right, it is limited to cold foods only. Okay, and what is important here, it is a cold foods and is used as artificial sweetener. Okay, till here you have written, but here you are going to add one more point from your side. You will write it as it is non-saccharide sugar. Okay, as it is non-saccharide sweetener or sugar. That's it. You will end off your answer here. So the examiner has a complete analysis. Okay, the student has written about aspartame. The student knows how is it getting converted to your harmful substance. Like that, the examiner will be clear and he will give you full marks. Done. So from your side, you have added this point and this point. Now, so next thing, what do you give me? Metal hydroxides. Yes, so metal hydroxides are better alternative than sodium bicarbonate for treatment of acidity. So here they said you're taking metal hydroxide, okay, and you're using as an alternative for sodium bicarbonate, where in the treatment of acidity. Why are you not using sodium bicarbonate? Right? So what will happen? Let's see. So basically, when I use excess of sodium, excess of hydrogen carbonate, what will it do? Let's take what actually is this. So that means, suppose they said we are using this, we are not using this. Let us start the reason from here. Bicarbonate, what will happen? Just see this. Bicarbonate is HCO3 minus. When it dissolves in water, what is it going to do? It gets converted to carbonic acid and it is going to release OH minus ions. Done? Yes? Fine. So what is now increasing? Here, hydrogen carbonate will make the stomach, means when to reduce acidity, more of OH minuses are released. So what will happen? This will make the stomach alkaline in nature. Correct? So you will write this reaction and say bicarbonates make stomach alkaline in nature because of release of OH minus. Alkaline. And what does it do? And triggers, means it will activate the release of what? Triggers the release of acids. Release of stomach acid. Okay, HCl. So that is the reason we are not using bicarbonates. Now, when I speak about hydroxides, what is the speciality? This I have ruled out. Now, when I come back to hydroxides, you can write metal hydroxides. What are the metal hydroxides? Like calcium hydroxide, magnesium hydroxide, all these. Calcium hydroxide, magnesium hydroxide, iron, ferric hydroxide, aluminium hydroxide. They are sparingly soluble. Hydroxides are sparingly soluble, means like very less solubility, and because they don't dissolve, what will happen? They will not increase the pH, isn't it? Correct? So you write metal hydroxides are sparingly soluble or insoluble. Okay, no problem. Insoluble. In which one? Insoluble in water when you put it in the stomach. But bicarbonates are soluble. So because they are insoluble, they do not increase. Insoluble, and hence do not increase the pH. Okay, above neutrality, that means above 7 it will not increase the pH, it will maintain that pH. That's the reason we are using hydroxides, not bicarbonates, because bicarbonates will release OH minus here. That is how you are going to do. Right, now these two questions are over. Let's see the next question which they've given us. They've given us aspirin is used in the prevention of heart attacks. Okay, so basically what is the role of aspirin? Aspirin, when I see, it acts as what the main property is, it has an anti-blood clotting action. That is the keyword which you have to write. So first you can write aspirin has, we'll put it in inverted commas, anti-blood clot action. It has anti-blood clot action. Okay, right. So this is the keyword. Here only you'll get 1 mark. And because it has this action, what will it do? It will prevent the, it will allow the free flow of blood. Instead of clotting it, instead of forming lumps, what does it do? It allows free flow of blood and prevents heart attack. But this is not suitable for all the patients because it varies with different people mode of action. So you have to be specific and careful. Everybody cannot take aspirin. You have to be specific, and with the doctor's suggestion only aspirin should be taken during heart attack. Done. So these are your questions. Hope this is clear, students. So what did they do in question number, okay, this is your question number 17 which I did, these 2 questions. After that, question number 18, they have given 1, 2 and 3 questions. Now, so in question number 19, now let's come back to question number 19. This is the question. So let us write. What do they give me? In question number 19, name the branch chain component of starch. So what is a branch? They asked you to write only name. What is the branch chain component of starch? It is nothing but amylopectin. Okay, nothing they've asked. Branch chain, because we have amylopectin, isn't it? So you have a branching at C1 and C6 carbon. So directly you can write the answer. Branch chain is amylopectin at C1 and C6. What is the next question they've given me? Ribose in RNA and deoxyribose in DNA. Right? So DNA differ in the structure which carbon. So they directly gave me ribose in RNA and deoxyribose of DNA. Vary in which position? They want you to write only the position, nothing else they want you to write. So simple. Ribose and deoxyribose, where do they differ? Means they differ at C2 position only. It's okay. Simply instead of if you have very less time, you can finish off writing the answer at C2 position. But for your information, let me draw the DNA and RNA structure. So this is clear for you all, right? So let me start. So when I said it is the DNA and RNA differ at second position, let me first draw DNA structure. So this is your DNA structure. It is written, means you will simply write it as 2-deoxyribose. Why are we writing just now? I said at the second carbon there is change in, means the second carbon position, there is change in the group. Right. So when I take RNA, I am going to again write it as ribose sugar. Now let's see. In both the things, first you have your oxygen, here also oxygen. Right. So link it here. So in biomolecules I have shown you how to draw the structures. Link it here. Here, this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon, and we get the fifth carbon here. Again 1, this is 2, this is 3, this is 4, fifth you get. In the first carbon, you have attached OH above and H down. Here also in first carbon, OH above and H down. In the second carbon, you have to be careful. This carbon, hydrogen is here, and in deoxyribose, you have hydrogen, both hydrogens. In ribose, you have hydrogen here and OH here. In the third carbon, you have hydrogen here and OH. Here in the third carbon, you have hydrogen and OH. Here in the fourth carbon, you have hydrogen down. Here in the fourth carbon, hydrogen down, and this becomes the fifth carbon now. This is CH2OH. Now this is the fifth carbon. Here also CH2OH. This is the fifth carbon. Okay, hope you understand this. So first carbon same, second carbon this different. Let us put this in the box, OH. So that's the reason we say deoxyribose and ribose, they differ at which position? They differ at C2 position. That is your answer. Hope this is clear, students. So this is why I have directly written C2 position. Now let's come back and do. Okay, this is done. Let me see A, B. Do we have any question? 19th, there should be a C question, isn't it? Okay, C2 position. Already I have drawn the structure here of this particular thing. Here I have drawn the structure. So this is here represented. Now C2. Then they said how many peptide linkages are present in a tripeptide. It's a direct answer. How many peptide linkages? Basically, when I have to speak about peptide linkages, okay, right? So I don't have place here. I'll be writing the answer for this here. Okay, let me write the answer here for the solution part. What is the answer? Peptide linkage means, first of all, whenever they say peptide linkage, remember one important thing. Nothing like what is important thing? Peptide means C double bond O NH linkages, peptide linkages. Now they said how many linkages? Peptide linkages in tripeptide. Tripeptide, simply as the name says, dipeptide means 2 linkages. Tripeptide means 3 linkages. Don't get confused. Like tripeptide means it has 2 peptide linkages. Remember that tripeptide is how many? 2 peptide linkages. How, ma'am, how is this? Let me see. Let me show you. Suppose if I take a tripeptide, for example, valine. Okay, let me take valine, glycine. Okay, means I'm just showing it at a stretch, right? So serine, like that, right? So here, when I take one example, this is a tripeptide, isn't it? All are linked together. So first of all, when I draw the structure of this, okay, valine, and let me draw the structure and explain. CH3, hydrogen, NH2, C double bond O, NH. Okay, this is one peptide. This is linked to one more C double bond O, NH. C double bond O, hydrogen, OH. Okay, right? So like this again, this links to one more. This goes on like this, NH. This is CH3. So this is H. This is C double bond O, OH. This is one unit, this is one unit, this is one unit. How many peptide linkages you have here? See here, this is one peptide linkages. This is one more peptide link. So how many did we write? We have written 2 peptide linkages. So in the exam, nothing to write about this, but I am giving you for a tripeptide, the number of linkages is only 2. Done? Yes. So this is your question. Hope this is clear, students. I have done this question. Let me show this to you. What did I do in question number? Now, okay, this is the next question. So I have picked up question number after question number 18. I have picked up question number 19. This is the first question. We have written amylopectin. This is the second question where I have shown you the structure of DNA and RNA. After that, I have turned the page and have done this question, C part, peptide linkages, where I have given the answer here, right? So let's come back and do the next question. That is your question number 20. But here, what do they give me? They have given me in this one only, basically in question 19 an OR question. Then question 19 only there is an OR question. Let's read that. So they said give 3 reactions of glucose which cannot be explained by its straight chain structure. Right, now let's see the OR question of your question number 19. What do they give me? Reaction, give 3 reactions of glucose which cannot be explained by its chain system. We have already read the question. So whenever we speak about glucose, right, you have to remember whether it is glucose or fructose, it's going to show us an Fisher projection structure, it's going to show us a Haworth structure, it's going to show us a closed ring structure, means it's going to form a cyclic structure, isn't it? Yes. So now when glucose molecule, when it shows a cyclic structure, so basically how is a cyclic structure? Now this is your carbon, right? 1, 2, 3, 4 and CH2OH. What happens here? This hydrogen, okay, let us write all these. HOH, next comes OH and H, next comes HOH, and this is H, and the oxygen here is linked to the first carbon. Now what happens here when I see aldehyde group basically is linked to, means this whole thing, and it is whatever first carbon is there, it is linked to the third carbon, and the oxygen here is linked to the fifth carbon. Is it free now? Not free, right? Aldehyde is not free. Because of this, its glucose is not going to show reactions which are specific to aldehydes. Once again, because of the cyclic structure and because of its linkage to the third carbon, it will not show specific reactions which are shown by glucose. What are the specific reactions? It's not going to show us, it will not show, it will, right, will not show what reactions? It will not give or show 2,4-DNP test. Okay, 2,4-DNP test is one. Then it will not, it does not give, it will not show or it will not give shifts test, it will not show shifts test, a positive shifts test, which is characteristic. And you know, it will not, the pentacetate, whatever is there, here it is pentacetate, isn't it? It will not react with hydroxylamine, okay, with hydroxylamine NH2O. This is also specific to your aldehyde. Right, and it will not form, like, you know, you can further write, it will also not form addition reactions, which HCN, we have NHSO3, isn't it? It forms acetyl, hemiacetal, like that. It will not react with addition NaHSO3, sodium bisulfate, as an addition product. It will not form any addition product. So these are all specific reactions of aldehydes. Because of this formation of the structure, it is not showing such reactions. So that is what they've given us. So I have done this clear explanation in biomolecules chapter grade 12. Please check the playlist. Now this is over. Now let's come back, and this question also is over, this question is also over. Now it's also over, all 19. See, 19th only they have given so many questions. Now let's start with the 20th question now. The following data was obtained during the first order thermal decomposition of N2O5. Okay, this is again an NCERT question only, direct question, simplest one. Let's see. So, okay, first order thermal decomposition reaction. First order they've given. I'll be very careful while writing the formula. That is first order rate constant formula we will write. They said, let us read again. The following data was obtained during the first order thermal decomposition of N2O5 at constant volume. This is the reaction. They have balanced it. After that, they have given the data. One is in time, one would be total pressure. I have to calculate the rate constant. Correct? Yes. Now let's start. First of all, whenever such question is given to you, pressure, you have to be a little bit careful calculating the total pressure. Let's see. First of all, they've given me N2O5, that is in gaseous state. What is that thing? They said it's dissociating into N2O4 and oxygen. Let us write that. It's dissociating into N2O4 gaseous state plus oxygen gaseous state. Now balance the reactions. This is 2, this is also 2. Done. So first of all, at T is equal to 0, what is the concentration of this given at T is equal to 0, they've given me 0.5 atmospheres, and if T is equal to 100, 0.512 atmospheres. Let us write. At T is equal to 0, the pressure is 5.5 atmospheres. Then it was 0 atmosphere here. This is also 0 atmosphere here. Now at time T, now the time has started increasing at time T. What was this one? It is basically 0.5 minus 2x atmospheres. Why? This is 2 moles, no? Isn't it? At time T, and from the original one, we are going to take out how much is dissociated. Minus 2x. Now, then it was, because the reaction has proceeded further, this will become 2x atmospheres, and this also will become 2x atmospheres. No, this is not 2x, it is only x atmospheres, because here when I say this is 2, this is only x, this is x atmospheres. Now, total pressure is equal to pressure of the partial pressures of N2O5 plus the partial pressure small p, this is partial pressures of your N2O4 plus partial pressures of oxygen. Total pressure, partial pressure. Let us add all three. First of all, when I take PT, how much is the partial pressure of this one? It is 0.5 minus 2x. P2O4, how much was it? It is nothing but 2x. How much was PO2? This is x. So what do I get? PT is equal to 0.5 plus x. Minus 2x plus 2x gets cancelled. Now x I'll take out. X is equal to, when this comes out this side, PT minus 0.5. Correct? Yes. So done. Now let's find out for your, this part I have got. Let's find out for P into O5. P into O5 is equal to 0.5 minus 2x. Now substitute this 0.5 minus 2 into, what is x value? X value is PT minus 0.5, isn't it? Yeah. Now substitute this, you get 1.5 minus 2 PT. Multiply these two. Now this is over. Now let us calculate at T is equal to 100 seconds. So T is equal to 100 seconds, how much? PT is equal to 0.512 atmospheres. Let us substitute that. P into 5 is equal to 1.5. I am substituting in this formula. Minus 2 into x value is how much? 0.1512. This is what we have got. Yes. 512 atmospheres. Now solve this. When I solve this, I get an answer of 0.476 atm. Now both the things I have calculated. One for P is equal to 100 I have calculated this part. Then I have calculated P is equal to 0, T is equal to 0 I have calculated. At T is equal to 100 also I have calculated. Done. Now let me take a paper and further solve. Now I am going to calculate the rate constant of this. They have given me first order rate constant. So K is equal to 2.303 by T log Pi by Pa. Now substitute 2.303 by 100 seconds. Log, how much did I get? Pi. I have initially got Pi is how much? 0.5 atmospheres, isn't it? Yes. So 0.5 atmosphere we have calculated. Then after that we have calculated 0.76 476 atmospheres. Correctly, isn't it? Right. So this is the part. So let's substitute. So here 0.5 atmospheres by 0.76 atmospheres. So when I solve this, and I solve this, log A by B is log A minus log B. Yes. 6. I get 0.4 minus 7 seconds. Right. Hope students this is clear. Now let us see once again anything you have done. First of all, let us go back to the numerical. They've given me the numerical. What did I do? I have calculated, I have written the reaction. I have calculated T is equal to 0 and T is equal to some time. I have done according to total pressure. Then I have substituted. I have got the answer. Then finally at T is equal to 100 also I have calculated. Because they have said rate constant is first order. I have taken the first order rate constant equation, then substituted, and finally got the answer. And the units for the first order rate constant is second inverse. Right? So this is a question. Now they have given one more OR question to me. So let's read that. So this is basically means they'll be giving you question, means a choice between two questions only. Remember, one theory, one question, they will not give you. Right. Let's read this. After the chemical kinetics numerical, they said two reactions of the same order have equal pre-exponential factors, but their activation energy differ by 24.9 kilojoules per mole. Okay, this is basically an Arrhenius equation formula. We speak in terms of activation energy only in the Arrhenius equation, isn't it? So calculate the ratio between the rate constants of these reactions at 27 degrees. Gas constant value is given. Okay, right. So what should I calculate? I have to calculate basically the ratio of K1 by K2. So calculate the ratio. Fine. First of all, what is the formula? Arrhenius formula. The Arrhenius equation. Arrhenius equation. What is Arrhenius equation? K is equal to A E raised to the power of minus EA by RT. Now I have two things. I have to calculate K1 value and I have to calculate K2 value. Correct? Now first of all, before that, you will take log on both sides. When you take log K here when you take log A, okay, minus EA by 2, because you're converting into log, you multiply with 3.303 RT. Yeah? Now I have got one formula here. Now take it for log A. Now first reaction, because I have to calculate the ratio for this. So what will I do? First of all, I am going for reaction 1. What do? I take log K becomes K1. Log A becomes log A. Okay, log A1, A only, because that's Arrhenius constant. Minus EA by 2.303 RT. For reaction 2, log K1 becomes log K2. This becomes log A only minus this is EA for the first one. This is EA for the second one by 2.303 RT. Done. Now subtract equation 1. Subtract 1 from 2. So log K1 by K2 is equal to EA1 minus EA2 by 2.303 RT. Now substitute log K1 by K2 is equal to, how much is EA1 value given in the numerical? They said the energies differ by 24.9 kilojoule per mole, they said. Correct? Right. So 24.9, right? So divided by 2.303 into gas constant 8.3, temperature 300, plus this into 1000. So the kilojoule per mole, they said. So when I solve this, I get an answer of 4.342. Now K1 by K2 is equal to, log comes this, so this becomes anti-log. Anti-log 4.342. When I solve this, I get an answer of 2.198 into 10 raised to the 4. This is a ratio. This is what they have asked us. So hope the students, I have taken 28th question. I have written the formulas. I have taken individually for K1 and K2. Then I say kilojoule per mole. And 27 degrees means 27 plus here converting into means your 273 Kelvin, 273 plus 27, it becomes 300 degrees centigrade. Right? So 273 plus 27 degrees we have added. Done. There we have got 300 and finally I got this answer. Right? Let's see the 21st question. Surface chemistry question. Here, what do they give me? Let's read the question. Right. So they said a colloidal sol is prepared by the given method in the figure. Okay. This is sol prepared itself by adding silver nitrate to Ki. Okay. What is the charge of silver iodide colloidal particles in the test tube? How is the sol form represented? I have to show the sol form which is represented. Done. So first of all, a colloidal sol. First of all, what should you see? You have to remember one important thing. So colloidal sol, they've given you what is combining. Done. You have to, because they have asked us how is the sol formed, you have to write the reaction and they say what is the charge. Both the things you have to remember. First of all, there are two things. Silver nitrate added to potassium iodide to silver nitrate, both the combinations. But here they've given us AgNO3 added to Ki. Correct? Yes, let's see. So first of all, what happens when AgNO3 is, you start your answer like this, added to potassium iodide. You have to be very specific. Solution. Okay, write the reaction. How does it do? What does it do? Whenever AgNO3 is added to Ki, what will happen? KNO3 is one part and AgI is formed. That is understood. So now, whatever AgI has formed here, it is a negative charge is developed on the sol. Yes. So this negative charge of AgI, why is formed? Why only on this? Because on AgI, or if I have to, let us not write like this, on this AgI, iodine comes in, adheres, and it's going to form AgI I minus, and the overall charge, what will happen? This overall charge is minus because of this attachment. So what did they ask me? They said, what is the charge of AgI colloidal particle in the test tube? What is the charge, overall charge? It is nothing but, it is negative charge, negative, because this we are taking excess. Negative charge is developed on the sol. This is the first answer. So how is the sol represented? Sol is represented as AgI by I minus. Done. This is the question. Remember that. Suppose if you have the other way, let me take, if you have, means the same concept. If I am going to add in this way, remember, if I have a test tube, instead of Ki here AgNO3, I'll be adding Ki, and you have AgNO3 here. Then what will happen? What type of sol do you get? Here you will be getting a positively charged sol. Positively charged sol. How do you represent? You are going to represent silver AgI plus Ag plus. This becomes silver iodide Ag plus. So the overall charge is positive if this is a combination. Remember that. Hope this concept is clear, students. Now let's see whether we have the second part in 21st question. Explain how the phenomenon of adsorption finds application in heterogeneous catalysis. Okay, so heterogeneous catalysis, they are asking me how is the adsorption phenomenon application, how is it shown? So adsorption is a surface phenomenon, we know. So whenever the reactants adsorb, suppose there is a duster, you have on the duster chalk piece dust, that is adsorption, correct? So whenever you have reactants on the surface of the swim, and suppose we are talking in terms of catalyst, that will increase the rate of the reaction, correct? So let's see what it is. Whenever I speak about heterogeneous catalyst, let us see the concept very quickly and then come back to that. Heterogeneous catalysis. So in heterogeneous, hetero means two different. Suppose I have an surface here. This is the catalyst surface. On this catalyst surface means hetero means what? Two different surfaces. One is this one, the other one is, suppose one is the reactant is the solid, means two different, solid and liquid, like that. So when these reactants, when I have two types of reactants, these two are reactants, both are of different physical states. Okay, right. So these physical states, let me take this red pen and use it. This is one physical state, this is one more physical state, like this. Okay, done. These two come and adhere on the surface of the catalyst. This is one color, this is one more color. Together, what do? They're going to combine and form an intermediate. This is one, and this is one more. Done? Yes. Further, what happens? These two combine together, means they absorb perfectly here. This also absorbs perfectly. Still here the bond is not formed. Here it absorbs perfectly. And it finally forms a product. Now this we have written here this color. Now I'll be showing a product formation in this way. This is your product. This is the catalyst surface. This is the intermediate. Okay, done? Yes. So here what happens? Adsorption of the reactants on the solid surface of the catalyst. Now these two are different, but here when they are adsorbing to the solid surface of the catalyst, what is it doing? The catalyst means it's increasing the rate of the reaction. The catalyst is increasing the rate of the reaction or not. So they should be attached perfectly like this on the surface, not hanging. So what are we saying? You write adsorption of reactants on solid surface of the catalyst increases the rate of reaction. That's it. You are going to write the answer like that. This is what the examiner wants you to express. Show the phenomenon and finally write it increases the rate because it adsorbs to the surface of the catalyst. Done. So let us see the question C part. What do they give me? Here they've given me, let us say the solution. Which of the following electrolyte is the most effective for the coagulation of ferric hydroxide which is positively charged? Very interesting. Simple question basically this is. They have given ferric hydroxide salt. They said it is positively charged. That means the electrolyte what we have taken is negatively charged. Simple. First of all, when you are speaking about a positive charge and a negative charge, the rule which applies here is Hardy-Schulze rule. Remember, according to Hardy-Schulze rule. What is Hardy-Schulze rule? Let us write first. They said greater the valency of oppositely charged ion. Okay, this is positively charged, this is negatively charged. Oppositely charged ion of the electrolyte. These are all electrolytes, isn't it? Of the electrolyte. What will happen? Greater is a coagulation. Done? Yes. So let's see. Now here NaCl. What is the charge when I break up? This is +1. Sodium and Cl is -1. You have to think about this only because this is positively charged. When I take Na2SO4, what is sulfate valency? This is +1 and means for 2 sodium it's 2 and this is minus 2. When I take Na3PO4, what is the valency? This is plus 1, again this is minus 3, isn't it? Right. So what did I say? Higher, greater the valency of the oppositely charged ion, greater the valency, more is the coagulation. Now what did they ask us? Which of the following electrolyte is most effective? Na3PO4 has a highest charge, so we will write Na3PO4 is most effective for coagulation. You write the full form, coagulation, that's what, because the charge is high, minus 3 is the valency, right students. So let's come back and do the next question, that is your 22nd question, right? Right. So when I come back to 22nd question, let's read this. What do they give us? Describe how the following steps can be carried out. Okay, this is basically a metallurgy question. Recovery of gold from leached gold metal complex. Okay, the first question. Next one, conversion of zirconium iodide to pure zirconium. That's also fine, right? So next important, formation of slag in the extraction of copper. Okay, all the 3 metallurgies. I have done a video based on the purification techniques, concentration methods, that is your roasting, sulfonation, all these methods, extraction, everything. Please watch the metallurgy playlist. All the videos of extraction of silver, gold, copper, zinc, iron, aluminium, all are kept, right? So they said recovery of gold from leached gold metal complex is said, right? So leached gold, first of all, when I have to remember the reactions compulsory, right? So leached gold complex, right? So what is a gold complex? I'm going to do the first question. The gold complex is auric cyanide into overall charge is this, so aqueous medium. I'm going to treat it with, I said, zinc, which is in solid state. Then what happens? There is an exchange of ions by displacement method. Okay, so this gold display means of this one, zinc displaces gold. This is highly reactive, isn't it? So zinc displaces gold, and what do I get? I get zinc cyanide, 4 valency, minus 2, and gold is out. Au is got solid state by the displacement method. So balance this reaction here. This is 2. Okay, this is also 2 Zn, 2 cyanide, aqueous, zinc solid. Okay, done. Right? Yes. So what is this process? So leached gold complex is treated with zinc and is recovered. How is it recovered? They've asked how is it recovered, and it is recovered by displacement method. So you can write gold is recovered by displacement method. Okay students, done. Right. Now let's see the second question. Conversion of zirconium iodide to pure zirconium. So zirconium iodide to pure zirconium. They've just asked what they asked me to write the reaction or what. Let me see this. Okay, they've not asked anything, simple. So basically zirconium iodide, Zr is I4. This one, when it's heated, it's associated into zirconium plus iodine. So what do? Zirconium iodide is decomposed on a tungsten filament. We have seen this reaction also. And when this is heated at 1000, not 1000, most above 1500, I think 1800, yeah, 1800 K, pure zirconium is formed. So you can write zirconium iodide is decomposed on tungsten filament and electrically heated to 1800 K. So what will happen? This one, pure zirconium metal is deposited on the filament. So this is the preparation. Done. Yes. So let's see. There is one more or question here. I think one more question we have missed out. I'm sorry for that. Here we third question we have not done. Formation of slag in the extraction of copper. Write the chemical equation. Okay, A part I did. Then I did the B part. Let me do the C part. What did we say? Formation of slag in the extraction of copper. Okay, slag means, always remember, it is mostly in metallurgy we speak in terms of slag, flux and all this. So slag basically comes out in the form of iron silicate only. Okay, right? In the extraction of copper, what do we do? Whatever silica means, that particular iron ore, whatever the material, left out material, other impurities, that is iron oxide, it's mixed with silica, and when this is heated, it will pull out the iron oxide in the form of slag. So they've asked me, what did they ask me? Formation of slag in the extraction of copper. Only this one they want, nothing, no extraction required. So you will write silica is added to the ore and heated. So what does it do? It helps to slag off iron oxide. You can write the name of this here. Iron silicate is a slag. Iron silicate. Done? Yes. Now let's see the OR question of your 22nd question. OR question is there because that OR question, I told they've given internal choice. So OR question is there. Let's see that. NaCl in froth flotation method. Done. So they said sodium cyanide, how is it used in the froth flotation method? They said, okay, what is the role basically? So NaCl in froth flotation, I've done a video also earlier. You can see what are the depressants, okay, what are the floaters, means some will float, like oils will float the whole thing above. So you have to remember only 2 or 3 things are there. So basically sodium cyanide is used as a depressant. Used as depressant. What does it do? It's going to depressant to separate zinc sulfide and lead sulfide. Where? In froth flotation method. So simple, you have to just write this word. Done. Next one, carbon monoxide in Mons process. They've asked me carbon monoxide in Mons process. Basically, what is Mons process? Just write nickel. It combines with carbon monoxide. What temperature? At 330 Kelvin to 350 Kelvin. And it forms a complex that is nickel tetracarbonyl. This one, when you further heat up to 450 Kelvin to 470 Kelvin, this breaks up and forms nickel plus CO. So 4, this becomes 4. Balanced. This is Mons process. So what did it say? What is the role of carbon monoxide? It's going to form, what is this compound? This forms a volatile complex. Nickel tetracarbonyl is a volatile complex. So let us write that. It is nickel tetracarbonyl. So you will write carbon monoxide, full form, carbon monoxide forms a volatile complex of nickel, and this is called nickel tetracarbonyl. That is a role. Right. Let's see the next question, the C part of 22nd question. coke is an extraction of zinc from zinc oxide. So basically, whenever I have to speak about any extraction process, so what do we follow? We follow concentration techniques where we do roasting, calcination. Yes, done. After that, we gradually take in the extraction process. After extraction, we'll do the refining process, right? So during and after that, purification techniques, the fractional distillation methods, and all these. Right here, during that process, we do a process called reduction, isn't it? So during that reduction, coke is added. Remember that, right? So basically, whenever you see coke acts as an reducing agent. Remember that, reducing agent. And what does it do? This coke, when it is added to zinc oxide, coke is nothing but carbon. It converts, it pulls out this zinc. This is the during extraction, this process is compulsory. So coke acts as a reducing agent and extracts zinc from zinc oxide. This is your answer, right? So let's come back and do question number 23 in my next video. Thank you for watching, students.